Seasonal relatives are a set of numbers that express seasonal variation in data. One use of that set of numbers is to de-seasonalize existing data. That's actually what's going on here in this particular scenario. Let's look. The director of Courtesy Van Transportation for Marion County has Marion County data for 2005. Now notice this. This is like history, past history. Okay. But the Marion County drivers warned the director not to study 2005 because 2005 was a weird year when we just didn't get the slowdown in transports you usually see between January and May. Oh, all right. Now this is the actual data right here. The question is, were the drivers wrong to suggest something was weird was happening during the early months of that particular year? Okay, you read that, you say, well, what's that got to do with deseasonalizing and seasonal relatives? Why would you want to deseasonalize existing data? Generally, you're not forecasting, you're investigating. If you have the data, it's history. It's something that has passed, right? Yeah, okay, got it. All right, so you want to compare a couple points from the past that are different seasons. For instance, it's always busier in January. That's 168 in 2005. And it's always quieter in May. I mean, we had seen that pattern with Livingston Medical Services. But the drivers are saying, you know, that's just, there's still something weird there, that's not exactly normal. We want to investigate that statement, so we're looking back. And our problem is that if we want to compare January to May, it's apples to oranges. It looks like it's dropping, but is that really only the influence of the season? You know, well, that normally happens. It normally drops. Or is there something to what the drivers are saying that particular year, no, there was that's not normal. There actually was something weird going on there. We can investigate that by pulling the season back out of the actual data. You say, well, how do you pull the season out of the actual data? How do you remove the season's influence from existing data? How do you deseasonalize? It's easy. You just divide. To deseasonalize, first off, deseasonalize. Why would I want to do that? Because I want to compare these unlike seasons. Divide the actual, meaning like, you know, like what actually happened, by the appropriate seasonal relative. Okay, now this is not answering that question. We're still trying to figure out if in fact there was anything to them saying that things were kind of weird in 2005, but this is the means of investigating. Now, give us a little bit more room to work. There's a blank table here. We have 5 unlike seasons that are past history to investigate. I'm going to draw some lines just so that I keep things straight. We're going to look at January, February, March, April, and May with the seasons removed. That's the theory. How do we do that? Well, first off, we need, for instance, the actual. This 168, I didn't calculate that. That's what actually happened in 2005, right? Oh, and I might as well. I'll just copy these over so I don't need to keep looking at 2 sheets of paper. The actual in 2005 in February was 122. The actual in March was 120. The actual in April was 108. And the actual in May was 70, okay? So we just copied that information over. The seasonal relative, right, we'd investigated the natural fluctuation in the demand for courtesy van transportation earlier and had created a set of seasonal relatives. What were they actually? Okay, taking you back, the seasonal relative that we calculated for January was 1.92. 1.2. For February, it was 1.08. For March, it was 1.01. For April, it was 0.88. And for May, it was 0.50. Okay, now that at this point is fact, because that's a result of work that we had done earlier. Oh, all right, now and only now, it's time to deseasonalize, so to speak. See the last column? Deseasonalized actual, that would be this, divided by seasonal relative. So in the case of January, the deseasonalized van transports is 168 divided by 1.92. I get 87.50. You say, okay, what is that? That is the deseasonalized van transports in January of 2005. Okay, what's that supposed to mean? 87.5? A little early for that. Don't think about that one number too hard. What's important is how does that number compare to the next couple numbers that follow? Because what is the deseasonalized van transports from 2005 in February? Well, we'd want to take the actual, 122, and divide by 1.08 to theoretically take out the influence of February. I get 112.96. In March, 120 divided by 1.01, I get 118.81. In April, 108 divided by 0.88, I get 122.75. And then in May, the mere 70 van transports divided by 0.5, I get 140. Oh, we have, now first off, in the far right-hand column, what have we done? We have found the deseasonalized number of van transports each month in 2005. How are we any closer to, what was it that we were asked to do? Were the drivers wrong to suggest something weird was happening during the early months of that particular year? Okay, here's the theory. We expect the number of van transports to vary between January and May. We'd been discussing that for a while. It's always really busy in January, and it's always a lot quieter in May. Now, here's the theory. We take a set of actuals from January to May, like we just did. We deseasonalize them. If the variation in the actuals, what actually happened, is pretty much explained by natural seasonal variation, the deseasonalized numbers should become quite similar to each other because we took out the reason that they were different. Now, take a look at 2005. Did these numbers, and this is really the question in our investigation, did these numbers become more similar to each other than these numbers? And the answer is profoundly no, especially if you look at January versus May, because not only, the 87.5 and then the 140, not only are those two numbers not any closer together, I'm disturbed by the fact, do you notice they have actually flipped positions? When you're looking at the deseasonalized numbers, January has passed May and it's actually lower, not higher. This is an indication that the actual variation between January and May, remember it was actually 168 and then in May it was 70, is not completely explained by the seasons. That there is, we want to address what the drivers said. They said they thought that 2005 was a weird year. We would agree, okay? Let's see. This confirms the driver's statement that 2005 was a weird year. What confirms? The fact that these two numbers actually all of these numbers did not become more similar, and especially considering these two numbers became distinctly dissimilar. we have found support for, in essence, the driver's statement, having deseasonalized the data. Now, you said, oh, okay, that means something weird was happening in 2005, and what have we discovered about that weirdness? Nothing. Okay, at this point, you know, well, what does this mean? Was January a really busy or unusually quiet time when it should have been busier? Or was May busier than it usually is when it should have been quieter? We can't really tell. And we certainly can't tell what the source of the weirdness was. All of this would have to be revealed by further investigation. You'd have to find somebody there that remembers 2005 and start asking more questions. The only thing that deseasonalizing the data did was tip us off to the fact that, you know, there might be something to that. In that one particular year, if you're interested, that pattern of numbers, it looks like there is something else at work other than the natural influence of the seasons.